I got it on Monday.
Awesome. Great. Okay. Well, we're going to use this book until the end of the school year. Okay. So.
Is the entire sixth grade using the second book, or is it just AP?
No, the whole sixth grade. This is not a normal year, but in a normal year, AP Math does half of seventh grade math.
Oh, so we're doing
But since we started so late, and you take the same STAR test, so anyway, so you're pretty much doing the same thing. But you guys move a little bit faster than everybody else does. So okay, so page 639, we left off on number 1 and 2 at the top. So number 3, we have 2 more inequalities. It says, is the given value a solution for the inequality? So why don't you take a minute and see if you can take care of question number 3 and question 4. So you're going to substitute for number 3, 20 for where Q is. And number 4, you're going to substitute 28 for where T is. And see if those both are solutions for the inequality. Hey, Google, set a timer for 1 minute.
All right, 1 minute, starting now.
Jacob, you're working on 3 and 4? Jacob? 3 and 4?
What?
Page 639, 3 and 4. You're working on it? You got an answer?
Oh.
Hey, Google, stop. Okay, so what did you get for 3? Is that a solution for number 3? Does that make that inequality true? Well, let's find out. So if we take Q, when we take 20 and put where Q is, that's 20 minus 2 is greater than 16. 20 minus 2 is 18. 18 is greater than 16. Yes, that's true. So that makes that inequality a true statement. Okay, so let's look at number 4. Now we have T. We're going to substitute 28 where T is. So we're going to put 28 minus 7 is less than 10. 28 minus 7 is 21. 21 less than 10. Is that a true statement? No. 21 is not less than 10. Okay. Okay, the table shows the number of different types of roller coasters in the United States. An amusement park wants to build a new roller coaster. They will only build a roller coaster if there is less than 10 of that type in the United States. Use this inequality, R is less than 10, where R is the number of a certain type of roller coaster, to determine which types will be built. So we're going to go over here and look at our chart. And we're going to look at this inequality, and we're going to plug each one of those in, right? So 460 is 460 less than 10? No. 111, 111 is not less than 10. 42 is not less than 10. 9 is less than 10. 7 is less than 10. 5 is less than 10. So the only 3 roller coasters they're going to build is the flying, the stand-up, and the suspended. Okay. Number 6. The table shows the number of different types of movies in Lavar's collection. He wants to buy a new movie to add to his collection. He only wants to buy a movie if he already has more than 15 movies of that type. Use the inequality M is greater than 15, where M is the number of the type of movie, to determine which types he will buy. Okay, so we're going to look at this inequality. We're going to drop this in. Is 18 greater than 15? Yep. Is 24 greater than 15? Yep. Is 12 greater than 15? No. Is 15 greater than 15? It's equal to 15, but it's not greater than. Okay, so that means that he's going to buy an action movie, and he's going to buy a comedy. Okay. Number 7, the number of text messages Leela sent each month is shown in the table. She can send no more than 55 messages each month without being charged. Using the inequality T is less than or equal to 55, where T is the number of text messages in a month, to determine in which month she exceeded her limit. If each additional text cost 25 cents, how much has Leela charged from January to April? Okay, so we're going to go look. We've got this inequality. T is less than or equal to 55. Well, 56 is 56 is less than 55 is T is less than, yeah, 56. That doesn't make any sense. 55. Oh, 55 is greater. No, yeah, that's less than what? Well, this is greater than 55. And this one is greater than 55. This is equal to, oh, I put a mark on there. That's 51. So there's no mark. So this is 51. So she didn't incur any extra charge there. And 55 is equal to 55. So there's no extra charge there. So the difference between 55 and 56 is 1. And the difference between 55 and 57 is 2. Right? So from January through April, right, she had 3 texts total that were over her limit. And so then she has to pay 25 cents for each one. So 3 times 25 cents. So she was charged an extra 75 cents. Okay. Okay, let's turn to page 640. Okay, so analyze relationships. Use one variable equations and inequalities to fill in the graphic organizer. So one variable means that you have one letter. It could be any letter you want, but that means you just have one letter. Okay, and an equation is a mathematical expression that has an equal sign in it. Okay, and that's where part of the word comes from, equation. Part of it is equal. So a mathematical expression with an equal sign is called an equation. And an inequality has one of the 4 less than, greater than, less than or equal to, or greater than or equal to. If you have one of these 4 signs, that is an inequality. Okay. So an example of an equation would be, for example, x plus 3 is equal to 10. Okay, that's an example of an equation. You have an equal sign. So what that's saying is this side is equal to this side. Okay, it's balanced. And inequality, an example of an inequality would be x plus 8 is greater than 20. Okay, and I have one of my signs. I have my greater than sign. So this is an inequality. So in this expression here, how many solutions do I have for x plus 3 equals 10? What would that number be? What number could I put where x is to make that equal? Some number plus 3 equals 10. 7. So my solution is 7, and I only have one answer. There's only one answer that will satisfy this expression. Okay? Now I have an inequality here, right? So what's a number that I could put in there that would make that a true statement? 20, yeah. So 20 plus 8 is 28. 28 is greater, right? Would 19 work? Yep, 19, would it work? Would 18?
Yeah.
18 would work. Would 17 work? Yep, 17 would work. 16? 16, 16. 15? Yep. 14? 14, 15, 16, 17, 18, 19, 20, 21, 22. Yep. 13?
Yes.
Yep. 12? No. Right? Because this is just greater than. There's no equal sign there. So really, I could keep on going, right? Forever. So actually, it is infinity. Infinitely many answers. So you can see with an inequality, you could have infinitely many answers that would satisfy your expression, whereas with an equation, you only have one answer. Okay. So let's look at this. We'll just finish this page and then that. So these are hot problems, higher order thinking problems. State 3 numbers that are solutions to the inequality x plus 1 is less than or equal to 5. So I'll give you a minute. All you need to do is come up with 3. It is an inequality, so you know you have infinitely many answers. You just need to find 3. Hey, Google, set a timer for 1 minute.
Okay, 1 minute. Starting now.
Jacob.
Jacob.
You working on number 9? Yeah, work on number 9 for me. Find 3 numbers that are solutions to the inequality x plus 1 is less than or equal to 5. Just find 3 numbers. Hey, Google, stop. Okay, so can somebody give me a number that will satisfy that inequality? Yes, ma'am. Yes. So 1 plus 1 is 2. 2 is less than or equal to 5. So that would work. Trip? Did you have a solution? Okay. Well, let's look at it. Let's analyze it. Okay. So here we have 5 over here, right? So it's showing that it has to be less than or equal to 5. Right? So the biggest number you can have on the left side would be 5 because it says equal to 5, right? So 4 plus 1 is 5. 5 is equal to 5. So that's the biggest number you can have, right? So that's, let me start over here. So that's 4, okay? So any number less than 4 would also work, right? So 3 plus 1 is 4. 4 is less than or equal to 5. Addison said 2, which works because 2 plus 1 is 3. 3 is less than 5. 1 would work. 1 plus 1 is 2. 2 is less than or equal to 5. Would 0 work? 1 plus 0 is 1. It's less than or equal to 5. How about a negative 1? Negative 1 plus 1 is 0. 0 is less than or equal to, right? And actually, you could go on infinitely going to the left, right? You could keep on going. If this is a number line, right? And I didn't do that very well. Okay, but here's 0. Oh, I did it wrong. Here's 0. Here's 1, 2, 3, 4, right? And then here's 0. And you could keep on going forever to the left on that number line, and it would satisfy that inequality. Okay? Infinite answers. Off into infinity. Okay, number 10. If x is equal to 2, is the following inequality true or false? Okay? So you've got a lot of stuff going on there. But if you look at your sign, you know that it's an inequality because it's right kind of like right here in the middle. Okay? So let's rewrite it with x is 2. So it starts with this fraction right here, which is kind of a conundrum, right? Can we simplify that? Do you think 8 divides into 112 evenly? Well, 112 ends in a 2. That means it's an even number. 8 is an even number. Right? So that tells me by the divisibility rules that it should work. So let's see. 112 divided by 8 equals 14. Okay, so I know this simplifies to 14. So if I take 14 plus x, which is 2, is greater than or equal to 15 plus, and now you're seeing 4x. When you see 4x like that, that is multiplication. Mathematicians are kind of lazy, and they don't like to write any more than they have to. So when you just see a number and an x, that's multiplication. Okay? Now, there are other situations in algebra where that means that's just 4x, but we're not there yet. But 4 times x, so that's 4. If I rewrite it, that would be 4 times 2 minus 7. So you're going to have to use PEMDAS, right? Parentheses, exponents, division, multiplication, addition, subtraction, and see if you can simplify this expression. I'll give you a minute. Hey, Google, set a timer for 1 minute. I guess Google's not working. Okay. So I'll just time it. Go ahead and simplify this expression. Tell me whether that inequality is true or false. Okay. What did you decide? Is it true or is it false? Anybody? You're absolutely correct. It is true. So let's see what this looks like. Okay. So I got 14 plus 2, so that's 16, right? Is greater than or equal to. Then I have multiplication. 4 times 2 is 8, right? So that would be 15 plus 8 minus 7. So then if I come up here, I have 16 is greater than or equal to 15. 8 minus 7 is 1. So that's 15 plus 1. So then I have 16 is greater than or equal to 16. So that is true. Okay. Okay, now here's kind of a heady question. Analyze if A is greater than B and B is greater than C, what is true about the relationship between A and C? Anybody have a prediction? Well, let's draw it out. Okay. So if A is greater, let's do this. Here's 0, right? If A is greater than B, then that means it has to be to the right of the number line, right? It has to be farther to the right because as you go on the number line, it gets bigger, right? So let's say A is out here. Okay, so A is greater than B, and B is somewhere in here. Right? So I just drew A is greater than B, right? A is here, B is here. A is farther to the right, so that means that's a bigger number. Then I have, and B is greater than C. So that means B has to be to the right of C. So that means C is here. So now if I look at the relationship between A and C, I can see that A is greater than C. Okay. Sometimes it helps if you draw it out a little bit. Okay. Number 12, evaluate. Explain why inequalities of the form x is greater than c or x is less than c, where c is any rational number, have infinitely many solutions. I can't remember. So any rational number, number greater than c would make the inequality true. Okay. So when you have x is greater than c, any rational number greater than c would make that true, would make this true. And also for this expression here, any rational number less than c, any rational number less than c would make the inequality true. So this goes to this one. Okay, 13, analyze. Analyze the relationships between the inequalities in each pair of inequalities below. Write the integers that are solutions to both inequalities in each pair. So I have y is greater than 4, and I have y is less than or equal to 6. So is there a number that I can use the same number for y that would make both those true?
5.
Yeah, very good. So 5 would make both true. 5 is greater than 4, and 5 is less than 6. Is there another number that would work?
6.
6 would work, right? Because 6 on this side, it's equal to 6. That would work, and 6 is greater than 4. So those are the only two numbers that will make both those inequalities true. Very good. Okay, the next one is x is greater than or equal to -3, and x is less than 0. So real quickly, if you can look, you have an equal sign here, so you know what. Let's try -3. If I put -3 here, -3 is equal to -3. If I put -3 for x, does that work? Is -3 less than 0? Yeah, it's smaller, right? Okay, so -3 would work. Is there another number that would work?
-2.
Yep, very good. -2 would work, right? Because -2 is greater than -3. If you're on the number line, right? If you're on your number line, here's 0, here's -1, here's -2, here's -3. -2 did I do that right? I overstepped on that. I apologize. Took you down the wrong path. -2 also works. Okay. There's one more that will work. -1 would work. So you have -1, -2, -3 will satisfy both these inequalities. Okay, C. M is less than 5, but M is greater than 3. What do you think?
4.
4, you're absolutely correct. 4 is the only number that will satisfy that. Okay, but last one, R is less than -1 and R is greater than 0. We draw a number line here, 0, right? So is there, so on this side of it, R is greater than 0. It'd have to be any number over here. And R is less than -1. So here's -1 here. It would be this way. They don't meet. There is nothing. There's no answer that will satisfy both those. It's none. Okay. So there's like 15 minutes left to class. So I'm going to let you use that time to finish anything you need to finish in Google Classroom or your packet. So 6 classwork. There's a ed puzzle. Hello. This is getting longer and longer. So you might also need, well, let's look, bless you. Let's look at Edgenuity. Maybe some people need some Edgenuity. Reports, attendance log. 6. Okay, so we're good there, good there. That's close enough. Good, good. Ms. Munoz, Edgenuity. That one's good. Jacob, you need to spend more time. Jacob, Edgenuity. You need more time on Edgenuity. That's good. That's good. That's good. That's good. Okay, so it just looks like it's Jacob and Shayla that needs that. Okay. And then we have an ed puzzle right here. We did this in class. This is in your packet, Math Minute 21, Math Detective. This is extra credit. This is the quiz. And does this work? I think this does. I had another one there that didn't work, but this one does. So there's a Scholastic Math there too. You want to click on that and then sign in as a student and sign in with your Google account. Okay, so you can use the last 15 minutes to do anything on there you need to do, or your packet.